In this Maths Olympiad question, we want to find all the integers a and b larger than or equal to 0, such that root a plus root b is equal to root 2009. So here's our equation, root a plus root b equals root 2009. One of the first ideas that springs to mind is to square both sides. So great, we get 2009 on the right hand side, we'll get an a plus b on the left, but on the left we'd also get two lots of root a root b. It's not looking like there's much to do with that method, so what we're going to do instead is we're going to subtract root b from both sides before we square. So we now get a equals the square of root 2009 minus root b. So a is equal to 2009 minus 2 root b, root 2009, plus b. I'm just going to bring the b and the 2009 together underneath the roots there. Now we know that a and b are integers, and obviously 2009 is an integer. So this means that 2 root 2009b must be an integer. But as the square roots of numbers are always either whole numbers or irrational, for 2 times the square root to be an integer, well, the square root itself must also be an integer. Now 2009 is equal to 41 times 49. Bit of a tricky sum that one, but you can check it for yourself. So we can split that up into root 49 times root 41b, which must still be an integer because it's the same number. Root 49 is 7, so 7 root 41b is also an integer, and by similar reasoning to above, if that's an integer, then root 41b must also be an integer. Now for this to be the case, 41b must be a square number. 41 is prime, so the only way 41b is going to be a square number is if b itself is equal to 41 times by another square. So we can say that b is equal to 41 times y squared, where y is an integer. Now if at the beginning we'd done this exact same method, but instead of subtracting the root b, we had subtracted root a, we'd go through the exact same steps. By the same logic, we'd get that a is equal to 41x squared, where x is also an integer. Now we've found expressions for a and b, let's substitute them into our original equation. So we get root 41x squared plus root 41y squared is equal to root 2009. Simplifying this, we get x root 41 plus y root 41 on the left hand side, and we've already worked out that root 2009 is equal to 7 root 41 earlier. Each of our terms is a multiple of root 41 now, so let's cancel that out and we get x plus y equals 7. We know x and y are integers, so this gives us a limited number of cases to now work through. So if x is equal to 7, y must be equal to 0. Putting them into our equations for a and b, we would get that a is equal to 41 times 7 squared, 49, which gives us 2009, and b is equal to 41 times 0 squared, which is 0. So here's our trivial case of 2009 and 0. If x is equal to 6, then y is equal to 1. Putting them into our equations for a and b gives us 1476 and 41. If x is 5 and y is 2, a and b would be 1025 and 164. If x is 4, then y would be 3, and a would be 656, b would be 369. Now our next case would be x is 3 and y is 4, but due to the equations for a and b being of the same form, this would give us the same two answers, 369 and 656, and so on. So x equals 2 and y equals 5 will give us the same answers as x equals 5 and y equals 2, etc., etc. So these are the only 4 pairings: 0 and 2009, 41, 1476, 164 and 1025, and finally 369 and 656. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.